Okay, we need to understand that these types of problems are, actually, they're pretty nice. Okay, so these are trying to figure out if we know a derivative, right? Here is the derivative of some function with respect to x. And we know one coordinate, right? When x is 2, y is -1. We're going to find the y coordinate of a second x value. Okay, we can do this by a couple of methods. Number one, we can find the equation, right? Finding the particular solution. Or we can do it using the fundamental theorem, which I think you're going to like this method better when we get to it. Okay, so method number one is we have to take the antiderivative of this function and then plug in x equals 2 and y equals -1 and solve for c. So here's that entire problem. So first we find the antiderivative, right, of this function with our plus c, right, because every integral gets a plus c. And then we plug in the initial condition, which is here in red. Y is -1, x is 2, and that allows us to find the value of c. So here is our particular solution, x cubed plus 2x squared minus 5x minus 7. And then we plug in x equals 3, and we get a y value of 23. Okay, so that's using the initial condition and our antiderivatives. So now we're going to use the fundamental theorem of calculus, right? So we have a lower bound to an upper bound of some function, right? This is f prime. So then these are the antiderivatives evaluated at b and the antiderivative evaluated at a. So let's see what that looks like. The lower bound is our first x value. Okay, so that's the lower bound of our integral. That's a. The integral from 2, and our upper bound is 3. That's the other x value given to us in our problem. Okay, your a's and your b's are always x values. Right? A left bound and a right bound, those are x-axis values. And then we have our equation, which is 3x squared plus 4x minus 5 dx, right? So we always have our function in there, equals. So according to the fundamental theorem, that's f of 3 minus f of 2. Right? It's the function evaluated at the top interval, right, or your b value, so f of 3, minus the function evaluated at your lower bound. Okay, that's just what the fundamental theorem of calculus says. So let's see what we know. We're going to go ahead and use our calculator to evaluate this. Okay, use our calculator to evaluate that. I know what f of 2 is, right? F of 2, we were told that's going to be -1. Okay, so I can replace f of 2 with -1. And now the only thing I'm going to have in my equation is f of 3. Minus a minus becomes a plus, so I can subtract 1 to the other side to get my value for f of 3. So let's see what that happens. So my calculator says that this integral from 2 to 3 is 24. And my last step is going to be to subtract 1 from both sides. So f of 3 equals 23. Oh, that's exactly what it was before. Okay? So maybe you like the first method if we have an initial condition and you really love taking antiderivatives. That might be the way to go. But if it's calculator active and you're allowed to use your calculator, then the fundamental theorem is the way to go. Or like this one says, there's no antiderivative, right, of sine of x squared. So we're going to have to use the fundamental theorem and your graphing calculator. Okay? So remember, we always start it by writing our integral. What is my lower bound? 1. It's the smaller of our two x values, and my upper bound is 2. Okay, and then I have my function, which is sine of x squared dx. That equals f of 2 minus f of 1. So now let's use our calculator to tell us what this value is. Right? We want to find f of 2. We know f of 1 is negative 5. So minus negative 5 will become a plus here, plus 5. 0.494508. That is what the integral from 1 to 2 of sine of x squared happens to be. And now my last step is minus 5, right? Minus 5 from both sides. And that will tell us that f of 2 equals negative 4.5055 when I round up. Okay, so yes, the graphing calculator, any calculator that will take an integral for you is going to be wonderful. Okay, this is a pretty classic AP calculus question about the fundamental theorem. Okay, notice we have the graph of f prime. So this is the graph of f prime. And when we take the integral of f prime, we get f's. Okay, so this is what we're using. Remember, we're using the fundamental theorem of calculus, which says if we take the integral from a lower bound to the upper bound of some function, right? This happens to be a derivative. That's f of b minus f of a. Notice there's no more primes on your answers, right? This is a prime. This is some type of a derivative. We take its antiderivative and we can evaluate it for f. So notice, this is f prime graph. We know that f of 2, f of minus 2 is 5. Right? F of minus 2 is 5. So this is going to be our lower bound because 0 is to the right of negative 2. Okay, so this is what we do for our calculus. We always write down the calculus. The integral from negative 2 to 0, right? This is your first x bound, your lower bound. This is your second bound. And since 0 is greater than negative 2, negative 2 goes on bottom and 0 goes on top. Right? Of our f prime function, we don't know what the function is, but it's f prime equals f of 0 minus f of negative 2. Okay, that's the calculus. That's what we write down every time. The integral from our lower bound to our upper bound of our function, which is f prime, right? Probably dx or dt, but we don't have an f prime of x. Anyway, equals the function evaluated at the top minus the function evaluated at the bottom. Okay, so here is the tricky part. How do we figure out what this is? We don't have an equation. We can't very well type it into our calculator. So what is the integral from negative 2 to 0? Okay, that integral is the area under our curve. From negative 2 to 0, that is this area right here. What is the shape of that area? That's a triangle. So what's the area of that triangle? 1/2 of the base times the height. The base is 2, the height is 4. So 1/2 of 2 times 4 is 4. Equals, I don't know what f of 0 is, but I do know what f of 2 is. What is f of 2? F of 2 is 5. F of 2 is 5. So if 4 equals f of 0 minus 5, what does f of 0 equal? F of 0 equals 9 when I add 5 to that side. So f of 0 equals 9. Okay, B. This is now your upper bound again because 2 is greater than negative 2. So it's the integral from negative 2 to positive 2 of f prime equals f of 2 minus f of -2, right? That is your fundamental theorem. So we need to figure out what is the area underneath the curve from -2 to +2. And we get this nice triangle with a base of 4 and a height of 4. So this has an area of 8. That purple triangle has an area of 8. And f of -2 is still 5. So when I add 5 to the left side, f of 2 equals 13. Okay, it's all about area under the curve. Okay, now our last one is an upper bound of 6. So I want the area from -2 to 6 of our graph equals f of 6 minus f of -2. Okay, so let's think about this for a minute, just for 1 minute. -2 to 6. Well, that involves from -2 to 2. I already know that that area is 8. And then this area below my x-axis, that's a negative. Any area below your x-axis is a negative area. So this is going to be minus. Okay, what shape are we dealing with here? A half of a circle. So that's half of pi radius squared. Half of pi r squared. So this circle has a radius of 2, right? Because it has a diameter of 4. So 8 minus half of pi r squared is 8 minus 2 pi, right? That's the area from -6 or -2 to +6. Okay, we cannot subtract those, so we write them down as simply 8 minus 2 pi equals f of 6 minus f of -2, which we know -2 is 5. All right, so when I add 5, I add 5 to 8. What is 5 plus 8? 13. So my final answer is 13 minus 2 pi. Okay, that is the value for f of 6. Okay, let's see some other types of KP calculus questions. So notice they are telling you right now what the area of each of these units are. This has an area of 4. This has an area of 9, right, below the x-axis, so it's actually going to be negative. And this has an area of 2. Okay? So the area under the curve, when we're finding our integrals, we're going to be using the numbers 4, 9, and 2 to figure out what these other values are. Okay, so we're going to find f of 0, f of 7, and f of 9 doing the exact same thing we did up there. Only now we don't have to calculate, we just have to use the information given. Okay, so here is all the work. Okay, 0 is less than 3, so 0 is your lower bound, 3 is your upper bound. We get this value from the graph. The integral means the area under the curve. So f of 0 equals 1. Okay, here 7 is greater than 3, so 3 is your lower bound and 7 is your upper bound. And because our graph is below the x-axis, we have an area of -9. f of 7 is -4. And likewise for f of 9, we have to do the -9 plus 2, and f of 9 is -2. So the last thing we do, we're going to plot this. It says, go ahead and put a graph on here, sketch a graph. So let's do that. When x is 0, y is 1. So x is 0, y is 1. When x is 3, y is 5. When x is 3, y is 5. Right? That's f of 3 equals 5. When x is 7, y is -4. Sorry. And when x is 9, y is -2. So whenever we have a graph, especially a graph, and we know that it's a derivative graph, okay? This is a derivative graph, and we're asked for values of the function. That is one of our keys or clues that we'll be using the fundamental theorem in order to evaluate. Okay, go be great. Goodbye.